We have Kay Teschke, who will be presenting for us today. And Kay has been a UBC faculty member for 32 years, which is incredible because she's only 35, and helped launch the Occupational Environmental Hygiene program a long, long time ago. She has had a lot of fun doing research on a wide range of topics, including occupational cancer, Parkinson's disease, lung disease, waterborne disease, and traffic injuries. And she cannot believe she is talking about mesothelioma again. So please join me in welcoming our presenter for today, Kay.
This is the first time I've used this, so is it working? All right. Well, so welcome everyone who's here, and also welcome to the people who are online, some of whom I think I even know. So yeah, this talk is a bit of a retrospective for me. It's talking about some of the types of research I've done, including on mesothelioma, and especially on occupation response relationships and exposure response relationships in epidemiology. And it's also a bit of a chance to look at some photos that are old. And this photo I've always really loved. It was one of the first things that someone sent to me in the mail after I started here. I'm not quite sure why, but it was great because this photo looks like this gorgeous snow-covered mountain, and it's actually from Cassiar, which is one of the places where chrysotile asbestos is mined in Canada, and this is the asbestos tailings pile. So I thought it's possible that there might be someone in the audience who doesn't know much about asbestos. But for those of you who do, please forgive me for going through some basics to start. So there are two broad classifications of asbestos, and chrysotile, which is the one that was mined in Cassiar and in other places in Canada, is the main one of the two classifications. It's often called white asbestos, and the classification it belongs to is serpentine, which has generally curly fibers, and they tend to be a bit longer than the other type. It's been mined in Russia, China, Brazil, BC, and Quebec, and other places, but those are major mining centers. The other classification to which both chrysotile and amosite belong, chrysotile is called blue asbestos colloquially, and amosite brown asbestos colloquially, they belong to the category of amphiboles. And amphiboles tend to have more needle-like, straight fibers, and they tend to be shorter. But if you look at the pictures, the two pictures here, you can see that both of them have straight components and both of them have curly components. So it's not nearly as cut and dried division as you might think. The amphiboles have been more commonly mined in South Africa, Australia, and Bolivia, and also other places. Okay, so this beautiful ad here on the left-hand side, I give credit to Chris Van Netten, one of our faculty members who's now retired, who found this. He found it in the 1916 edition of Scientific American, and it advertises asbestos, and it says, when you think of asbestos, you think of Johns Manville. And Johns Manville was the major retailer and wholesaler of asbestos products, and I know that they no longer hope you think of them when you think of asbestos, because they have been sued and sued and sued until they declared bankruptcy for one section of their company. But you can see that at that time, asbestos was thought of as something very positive, and positive in really a public health way. Two of the things they're advertising here, this one here is actually a theater curtain on the very far left here, and then beside that is a roof. And it was a great product for preventing fires from spreading because it does not burn. And so it comes from the name. Asbestos is ancient Greek for inextinguishable. And so that is a great characteristic. In fact, apparently, mummies have been wrapped in asbestos cloth, and because it stays, very easily preserved. So it had characteristics that were useful from the public health side, and so it's nice to know at least some of the uses were that, but there were many, many other uses that were promoted in the 20th century. And what you can see on the right-hand side is one of those. Asbestos was sold as fake snow. It was used here in The Wizard of Oz in the poppy field scene as fake snow. And what you can see at the bottom is actually a package of fake snow that was marketed as a retail product at Christmas time in the 40s and 50s. Not necessary at all. When did the evidence of association between asbestos and mesothelioma start showing up? Well, the earliest case reports were in 1935. Mesothelioma is an incredibly rare disease, so being able to see it somehow frequently was an alert that there's a problem here. Epidemiological studies of asbestos and cancer, including mesothelioma, started showing up in the late 1950s and the early 1960s, and they particularly focused on two groups, asbestos insulators, and you can see a photo of someone here spraying asbestos insulation, and the chrysotolite miners in South Africa. So those were the two big groups that were studied, and for sure elevations in risk to both mesothelioma and lung cancer were found. So what is mesothelioma? Here you can see a Frank Netter drawing on the left-hand side. It's cancer of the lining of organ systems. The dominant one related to occupational exposure to asbestos is pleural. It's a pleural cancer, so you can see it's the lining of the lungs, all that incredible thickening around the lung. And you can see it starting to extend around the heart and then also move to the other lung. And on the X-ray, you can see, now this is not from the same thing because this is a drawing, but this is an X-ray of someone who has a mesothelioma on the same side. And you can see how much smaller the lung looks, the airy parts of the lung, and you can see the thickening around the lung and around the heart. The next picture is kind of sad, so for those of you who don't like sad, you might want to close your eyes. But I think it's important to show because the person who it shows wanted this message to get out. So this is a fellow, Blaine Canart, and on the left you can see a picture of him when he was 50. He was a millwright in one of the petrochemical plants in Sarnia, Ontario. And in the petrochemical plants, like manufacturing plants of pretty well all type, gaskets, pipe insulation, and so on were pretty well all used asbestos. The picture on the right-hand side shows him shortly before he died at age 58, so just 8 years later. He wanted his case publicized, and he was the subject of a Globe and Mail article in 2004, and that's what these pictures and this quote are from. I always thought this was particularly striking because I don't think many people have an image in their mind unless they know someone who's had cancer about what a wasting disease it is. I always associate with this kind of wasting, sort of in my career, with AIDS. And of course, we've all seen pictures of people with AIDS and how they waste away as they're dying. But it's very similar here. The other thing that's interesting here is he was very healthy at age 50 and dead at age 58, and that's also indicative of mesothelioma. Once it's diagnosed, very few people live past a year, so it's a very quick disease. There's no known cure. There's palliative treatments. Okay, so the Globe and Mail actually has been pretty good at trying to advertise the problems with mesothelioma, and 10 years later they did a whole other sort of expose or a long series. And what they did for this was they gathered information from all the workers' compensation boards across Canada for this 6-year period from 2007 to 2012. And you can see that you could look at it in a few different ways, but you can see by doing it in this particular way, looking at deaths that were approved for workers' compensation, you can see that in this period, the top cause of death that was compensated was mesothelioma, and over that whole period, there were 1,200 mesothelioma cases compensated. There were other asbestos causes of death compensated. You can see about halfway down there's asbestosis, which is also only related to asbestos exposure, about 500. There's 2 other places that lung cancers from asbestos might be included. I don't know the details here. Site-specific cancers and then other cancers. But I should point out that in the epidemiological evidence, you would expect about 2.5 to 5 times as many lung cancers as mesotheliomas from asbestos exposure. So the fact that we see 1,207 mesotheliomas means that there should be a lot more lung cancers, but because lung cancer has many causes, it's more difficult to distinguish that the cause may be asbestos, and it's rarely, people rarely submit claims for lung cancer due to asbestos exposure. The difference with mesothelioma is it's almost a very exquisitely specific cancer that's attributed almost completely to exposure to asbestos, so it's easier to realize that there might be a claim. Having said that, I'd like to show you this data from British Columbia. Now, this data comes from a study that was done here by Tracy Kirkham, Paul Demers, Chris McLeod, Lil Tamburek, and Mika Kuhorn. And this shows the mesothelioma cases diagnosed in British Columbia from 1970 to 2005. You can see them in the light gray bars in the background. That's the number of new cases diagnosed and reported to the BC Cancer Agency. In the dark gray bars in the foreground, what you see is the number that received compensation from the Workers' Compensation Board. And you can see that it is far, far fewer than the number of cases diagnosed. So a question would be, why aren't they all getting compensated? The EPI data suggests that about 80% of all mesothelioma cases are incurred in exposures that happened at work. So you should see that those dark gray bars are about 80% of the light gray bars. We did a study, Maria Barotevena and I did a study in the 1980s over a 10-year period where we looked at all compensation claims and compensation requests for compensation for cancer in that 10-year period in the 1980s. And when we looked at all the different cancers, there were many cancer claims that were turned down, but mesothelioma claims were never turned down. There was not a single mesothelioma claim in that period that was turned down. So the reason for the difference between the dark gray bars and the light gray bars in this period is because people were not making claims. So in fact, in the more recent years, the BC Cancer Agency and WorkSafe BC came up with a program so that physicians of patients who'd been diagnosed with mesothelioma were sent letters to try and encourage them to discuss with their patient the possibility of workplace exposure and the possibility of claims. And that did increase the claims somewhat, but still not to what would be expected. So all of that is kind of the background that I wanted you to know about. For a study that I did with others from the University of Washington, is actually the study I did for my PhD, to give you an idea that we already knew virtually everything that was said, that I've said there. So this study was not a study to figure out whether mesothelioma was caused by asbestos. This study assumed that we all knew that, and that in fact, mesothelioma, the disease, could act as a way to figure out where exposures had been taking place that we might not have known about. So it was used as a surveillance tool for exposure, disease to exposure. So it's a kind of reverse thought. This study was inspired by a really interesting one that was done in Italy shortly before that. In a particular area of Italy, they were observing, the cancer registry was observing that there were far more cases of mesothelioma than other areas, and they didn't know of a cause. They didn't know where the asbestos exposure was taking place. So they did a study. They figured out that the people who were getting mesothelioma were working in the textile industry in this area. And so they sent out hygienists to a variety of the textile plants. They found out that these were plants where they used rags and made them into other textile products. The rags themselves did not contain asbestos, but the rags had been baled in these large sacks that used to be used to bale and transport asbestos. In fact, the bales on them had in large letters asbestos, but that's not the word for asbestos in Italian, and people didn't know. I'm not sure they would have recognized that it was a problem anyway. So that was the idea behind our study. So I just wanted to show you a couple of the results. There were many, many more results, but I just wanted to give you a bit of an idea. So the top two, shipbuilding, repair, and demolition, had a very highly elevated relative risk or odds ratio, 7 times compared to other occupations. And installing insulation, also very high relative risk, about 6-fold higher than other occupations. But there were 2 others that I have here at the bottom of the page where we would have thought maybe there could be an elevation because brakes are made with chrysotile asbestos, but we did not see an elevation. We saw a null result for vehicle mechanics and also for the task of brake lining installation or repair. And I wanted to point out this photo, which was given to us by David Bates, who used to be the Dean of Medicine at UBC and an occupational environmental health researcher. This is a picture of people working in Rogers Pass area, the rail tunnels, and you can see they're going to be insulating the tunnel with asbestos, and you can see the incredibly casual way that it was handled. Okay, so we did that study, and I got it published and presented it to folks at the compensation board and a few other things, and didn't really think about it. I was busy doing other things, and in 2007, so 10 years later, I got an email on a listserv from this woman, Laura Welch, who wanted people to sign on to this brief that she had written for the Michigan Supreme Court. And she was asking to the listserv. So typically I don't just sign on to things. I was ready to delete it. In fact, I'm sure I did delete it, but I got an email from another person who is from the US, Tim Tuccaro, and had just recently moved to start working at Simon Fraser University. And he said it was really important that if I agreed with this brief that I should sign on. So I read the brief and I agreed with it, and I did sign on. And you can see mine is one of many signatures here. Virtually all the other people who signed on, including Tim, were Americans. So American epidemiologists and American physicians. So I was pretty well the only Canadian. I didn't realize how important me signing on to that until a year later. I got a call from two attorneys from this company. This company is a US law firm that regularly does 2 kinds of claims related to mesothelioma and asbestos. The first kind is just claims for workers' compensation, which often end up in the courts or at least in administrative tribunals. They tend to be handled by private insurance companies rather than by government agencies or quasi-government agencies, as in Canada. The other is what they call toxic tort cases, so people who maybe had tertiary exposure to asbestos and are suing the asbestos companies. The asbestos companies also got involved in the compensation claims because they often had something to lose in those as well. So they told me that our paper, and that result I told you earlier about the null result for vehicle mechanics and brake repair workers, had been repeatedly used in these court cases to prove that brake mechanics and vehicle mechanics could not get mesothelioma arising from their job. And they asked me if I would be willing to be involved in court cases if I really if I really agreed with the amicus brief that I'd signed on to. And at the time, my career was really busy, and I said, oh, I can't do that. I said, would it help if I just did one? So they said, yes, that would be fantastic. And so they asked me to do a deposition. That deposition was held in Vancouver to make my life a little easier. They sent their 2 lawyers. A US court reporter was sent up, and there were 8 lawyers from vehicle manufacturers, brake manufacturers, and asbestos companies. And they grilled me for a day, and it was totally exhausting. So once again, I heard that testimony had been used in multiple court cases, not just the ones that they were involved in. So again, I was sort of not thinking about it anymore. And another 10 years later, well, not quite 10 years, but close, I was informed by one of the lawyers last fall that this review article had just been published by the Annals of Occupational Hygiene. And he wanted me to contact one of the authors, Paolo Bofeta, who he knew I knew, and ask why he had been involved in this paper. So I read the paper, and when I read the paper, I realized that this review article, could be used in the same way as our earlier article. In fact, in this paper, they called our study one of the top-tier studies because of some of the very interesting ways we've done the analysis. Anyway, I was fairly sure that this could end up being used in the same way as our paper had been used. And so I decided it wasn't really appropriate for me just to talk to one of the authors, but that really what I needed to do was make sure that what I had said in the deposition a number of years earlier got out into the public domain. So I decided to write a letter to the editor about this article, and I did it completely independently. I didn't talk to anyone about it, and I sent it in to be published. And I was quite surprised, taken aback actually, when Noah Satius, the editor, said he was sending out my letter for peer review. And I thought, oh, that's weird. I just thought letters to the editor just get looked at by the editor. It's either sane or not sane, and then they publish it. But no, he sent it out for peer review. It was peer reviewed by a couple of people. I made a few small changes, and then it was published. And then, of course, I realized later that the reason that Noah had asked it to be peer reviewed is he wanted it to be peer reviewed so that people could use it in the same way as they would be able to use this article, which had been peer reviewed. So there were 2 issues that I brought up in the deposition, and one of them was one that was addressed in that review article. So that's the first issue. Right at the beginning of that article, excuse me, it said, studies of motor vehicle repair activities and brake repair activities provide an opportunity to examine the risks of mesothelioma from chrysotile exposure. So the first issue to me is that true? So chrysotile asbestos is used in brakes because of its indestructible qualities and its lack of flammability. It's very indestructible in that high friction situation. That's why it's used in brakes. It's also used in many, many other products. In fact, chrysotile asbestos is the most commonly used asbestos. It's used in asbestos cement products like sewer pipes, for example, and water pipes. It's been used in floor tiles. It's used in textiles because it's very curvy and can be easily woven. It has been used in plaster to make it stay together better. Anyway, just so many products. It's unbelievable. And one thing that has been shown in epidemiological studies is the risk relationship is less strong for chrysotile than for the amphibole types of asbestos. So the number of mesothelioma cases per unit exposure is lower for chrysotile than for amphiboles. And you can see what that has led to. You can see that's an example of a package of brake linings, and it says chrysotile means safer brake linings. So studies of vehicle and brake mechanics have often found relative risks that are null or very low elevations, usually not statistically significant, and that certainly was the case for our study. But you need to ask why. Why was that the case? So our study was done it was accruing cases in the early 1990s, and the latency between asbestos exposure and mesothelioma is long, typically on the order of 30 to 50 years. So you're talking about people who had exposures from the 1940s to the 1960s. So think about what a vehicle mechanic in British Columbia at the time, what would their working environment be? Well, the average vehicle mechanic worked in a small gas station. They would probably be a jack of all trades. They probably would pump gas. They would probably sell things from their little store. They do a little body repair work. They would do engine adjustments, tune-ups. They might repair the odd set of brakes. They might do transmissions. In fact, when we ask people who were vehicle mechanics whether or not they'd ever done brake repair work, and this was true of 3 other studies that also asked, many studies of vehicle mechanics don't ask, about 35% of them said they'd never done brake repair. So that's an example. Even those who did do brake repair, how frequently would they do it? Infrequently. So jobs are often used as surrogates of exposure when you're trying to see the relationship between exposure and disease. But you have to ask, are they good surrogates? So for example, you can think that if someone is a finishing carpenter, the chance of them being exposed to wood dust commonly, daily, is high. But if you wanted to know whether a nurse was exposed to anesthetic gases, for example, well, sure, if she worked or he worked in surgery. But if she or he worked in a mental health setting or a public health clinic and so on, no, almost certainly very rare, if ever, exposure to anesthetic gases. So is the job a good surrogate? So in fact, what's interesting is that chrysotile is classified by the International Agency for Research on Cancer, IARC, as a group 1 carcinogen, meaning it's a known human carcinogen. Well, how did they determine it? In fact, they determined it from studies of 2 other occupational groups. One you can see in the picture here, the large picture here. These are chrysotile textile workers. They make fabric out of chrysotile. You can see that they're exposed every day, all day. And the other group is chrysotile miners. they even have less exposure than the textile workers because the ore often doesn't have asbestos released in the same way as would be released for the textile workers. But they are working with it much more commonly than brake repair workers in our study. So these people have exposures, these jobs have exposures that are consistently high, consistently present, and so they're a job that would be reasonable to use as a surrogate for chrysotile exposure. Now I'm going to switch from the relationship between exposure and disease in the population, so trying to look at the causal relationship at the population level, to the individual level. So this is thinking about trying to get someone compensated for a disease that they may have incurred in their occupation. So that individual level decision about cause is much, much more difficult. In fact, you never can be absolutely sure for an individual. And in fact, this was an issue that came up a lot in the 1980s, and finally a series of studies were done looking at this issue. So this is thinking about how a physician who's being asked to make a determination about whether an individual should be compensated for an occupational disease, how they think about causation. They are being asked, is it probable that this person has their disease because of occupation? And when this was studied, they asked physicians what level of certainty they needed to feel before they used the word probable. And it turns out that on average, it was greater than 80%. To them, that's what probable meant. Well, it turns out, of course, that compensation is not a medical issue. It's a legal issue. And so the legal definition of probable is what they were being asked, but they didn't recognize that's what they're being asked. The legal meaning of probable is more probable than not, which means greater than 50%. So this was kind of a new development in that time period. And just to show how some epidemiologists and also compensation boards in Canada started thinking about this, here's something from an article written by a group from McGill headed by Ben Armstrong. He is a biostatistician, and he was trying to help compensation boards in Canada figure out when to compensate aluminum smelter workers who had bladder cancer. Bladder cancer can be caused by a number of different things. It's not an exquisite relationship like mesothelioma and asbestos exposure. It has a variety of different causes, but one of them is exposure to benzoate pyrene that can occur in aluminum smelters. So he came up with this idea that determining more probable than not can be done by the epidemiological concept attributable risk. I'm just curious how many of the hygiene students have heard of attributable risk in your epi course? Okay, so that's great. So it's, I'm glad that that's true. So you have the probability of causation is equal to the relative risk given exposure, so in this case benzoate pyrene, minus 1 divided by the relative risk given exposure. And so when the relative risk given exposure is 2 or more, then the probability of causation is greater than 0.5 or greater than 50%. Right? So that's what he said. That's what we should use as the deciding point, a relative risk of greater than 2. He actually took it a bit further than that, and here you can see a cumulative exposure in this left column, and then the relative risk, and then beside the relative risk is the upper confidence limit on the relative risk, and then the probability of causation from the attributable risk. You can see that they recommended using the upper confidence limit as the dividing line. So they were suggesting that where the upper confidence limit was greater than 2, then that gives the benefit of the doubt to the worker, and that's where you have the probability of causation of greater than 50%. So that's what they recommended. It turns out that this idea took off like wildfire in the American court system, the toxic tort system, and workers' compensation. So here you have, in our study and many other studies, studies of vehicle and brake mechanics where the relative risk is less than 2, and so no compensation. So this is the second issue that I wanted to address. Is it appropriate to require evidence of elevated associations between an occupation and a disease to decide whether someone got that disease as a result of exposure in that occupation? So let's think about that for a minute. The first thing I want you to think about is if for every person who's had an occupational disease or a disease that's likely to do with occupation has to make sure that their occupation has been studied with relationship to that disease, and that that occupation has to have a relative risk greater than 2, there are probably thousands of occupations that will never be studied with relation to that disease. First of all, there are many occupations where there are very few people, so it's impossible to study them. There's also occupations that are so dispersed, either in a country or in the world, that it makes it very difficult to study them. And of course, there are occupations like vehicle mechanics that have many, many different levels of exposure. So let's go back to the case that I was asked to comment on for that original deposition I did for the American law firm. In that case, the person who was fighting for compensation was a person who had been a brake mechanic for a major automaker. He had repaired and replaced brakes every day, all day, for 40 years. He used compressed air for cleaning, and he sanded brakes to repair them. So just think of this person's exposure compared to the average person who was a vehicle mechanic, or even who said that they did brake repair in our study of people in BC. We don't have a major brake manufacturer in BC. We don't have a major car company in BC. And at the time that those folks were incurring any potential asbestos exposure, there weren't even specialty brake shops around. So the important thing here is, once again, jobs are only useful in this situation as surrogates of exposure. It's the exposure that causes the disease, not the job. And you'll notice that in this original article by Ben Armstrong, what is listed here is not cumulative exposure to a job, although even that would be better than just job or not. They're looking at cumulative exposure, in this case, to benzoapyrene. So just think what you're saying if you're saying that somehow brake mechanics or vehicle mechanics can't get mesothelioma from asbestos exposure. You're basically saying that somehow brake mechanics are immune to asbestos, that they are superhuman. They're the only ones who couldn't possibly end up with mesothelioma. Of course, that's absurd. And just to show how absurd the situation is, here is the flip side to what's happening in the US. This is compensation in British Columbia. In British Columbia, there's a presumption of exposure to asbestos if you have, or if you can show you've had asbestos exposure at work. There's a presumption that your mesothelioma is from that exposure. And just to show you, in 2014, these are some of the occupations that were compensated in British Columbia for mesothelioma: fisher, draftsman, baker, steel fabricator. All of these, well, maybe not the steel fabricator, but the other three, most people would not think of asbestos exposure. But clearly they were able to demonstrate they'd had some kind of asbestos exposure, and that gave them the presumption of compensation. Highly humane in the devastating diagnosis of mesothelioma. So that's what I wanted to say, and I'm happy to hear comments or questions.
Thank you very much, and we have a couple of questions.
Sorry. Yeah, just to comment, Kay. In the 70s and early 80s, there were at least 2 shops in the Lower Mainland where people were relining brakes. So they were cutting, sanding brake linings all day, every day in these shops. And some of them, I visited those, they were primitive in terms of, not having much control at all of the dust. So we do have a few people who might have been, were in that sort of industry and might have been called auto mechanics or auto repair people.
They almost certainly wouldn't have had mesothelioma by the early 90s.
No, well, but these industries have been around for a long time.
No, maybe. Even so, they would have been diluted by the folks who were less exposed.
Oh, yeah, yeah. But I'm saying individuals that worked in those shops, to my way of thinking, if they got mesothelioma, it would have been a pretty obvious link to their work.
Oh, yes. I'd even think that, many who may not have been exposed as much as they had would. I'm just saying, what I was trying to say was not so much that brake mechanics here vehicle mechanics here should never be compensated, but that you shouldn't demand that that there is an overall relative risk of 2 or more for in epi studies.
Yes.
Each individual should be, for compensation purposes, their exposure needs to be taken on an individual basis. But they were trying to use this population health or population epi study as a way of making a decision about an individual's exposure and their potential mesothelioma compensation.
Right.
So that's the connection that needs to be broken.
Exactly. Yes. And I've run into 2 or 3 cases in my travels where, like, I ran into an electrician that suffered acute mercury poisoning on the job. Well, he was one of a few thousand electricians that sometimes broke 1,000 fluorescent lamps in a day, and thereby got a mercury exposure. But for the vast majority of electricians, that wouldn't happen, right? Yeah. So
So thanks, Kay. A comment and a related question. So the interesting that relative risk greater than 2 has even been used more obscenely, I guess, is that in terms of it's used often legally as a way to judge quality of studies. So the strength of the association. So often you'll see in a legal setting, if you present evidence of a study, let's say that has a relative risk of 1.5, they'll say, well, that's not causal because the strength is too small. And this is particularly the case for things where you may have, let's say, multifactorial diseases. So that's where I see it all the time. And they say, oh, well, this can't cause it. Your relative risk is small, but you may have, prevalence of exposure that's 60%. So it's a huge deal. And that won't be accepted. So it's interesting. And then I guess
that's actually based on the Bradford Hill criteria, and they were worried about the potential for confounding at relative risk less than 2. That's on the causal chain, not at the compensation level, but at the, I understand what you mean.
Yeah, and so, but the question, I guess, is, so here you have a case where, and I always use asbestos and mesothelioma as sort of the rare example where when you have a disease, you can, with high certainty, you can say it's caused by a particular exposure, which is really the extreme rare example. Most of the things we talk about, there's multiple ways to get that disease, some of which could be, a particular agent or particular exposure. So this is really depressing.
I know.
And, and I'm just wondering what thoughts you have about the sort of, this for the sort of more, the more complex but much more common situation where it's not so clear.
Yeah, I mean, well, the first thing here, I think, is that for this issue, and it's true for the lung cancer case, for example, here, is just to remember that the issue is exposure, not job. So that's the first thing. And once you disentangle that, then it opens up the potential for that exposure-response relationship to have a relative risk greater than 2 and be accepted more easily. And I mean, the relative risk for asbestos exposure and lung cancer and for mesothelioma and lung cancer are huge, including the ones for chrysotile. So that's an easy, once you figure out that what you really care about is the exposure, and don't worry, don't think about the surrogate that job is, because it's not a very, it can be a poor surrogate. But then the issue that you're talking about, were you talking about compensation cases, workers' compensation cases, or toxic tort cases, or just thinking about whether it's a causal relationship? Yeah. Yeah. I mean, I guess what I would say is that for the Bradford-Hill criteria, the strength of association is only one. And consistency is probably the dominant one, and trying to tease out, I mean, the other thing you can do, and I think air pollution, I mean, that's your field. One of the amazing things that's been seen on the flip side is when interventions are done, you see effects. That's dramatic, and it's been shown, and that should be evidence too. So I think that the point of the Bradford-Hill criteria is that you need to look at a whole series of criteria, not just one, to figure out that relationship. And if you can do interventions and show that they have an effect, that's very powerful.
Thanks, Kay. So fascinating story, as always. I have a comment and a question. Just to update the audience, in addition to the work that I think you did with Maria in the 80s, is that the 80s?
Yes, it was, yeah, 1980 to 89. Mm-hmm.
So did more recent work with Terry Bojo when he was at WorkSafe BC to answer the same question, but more recently. And again, they compensate all mesothelioma cases that present, even in more recent data. I'm curious, as a question, if you look back now in hindsight, would you have done anything different methodologically with that original study around using occupation as a surrogate measure? Would you have, for example, excluded some occupations because they weren't good surrogate measures for exposure? Would you methodologically have said, these are, occupation is a good surrogate for exposure, but here it's not, so we won't look at those? I'm just curious, in hindsight now, however many years later, would you have done anything different methodologically with that paper?
So the answer to that is no, because the purpose of our study was not to find out if there was a relationship between mesothelioma and asbestos, and so I wasn't using the occupation as a surrogate for exposure, but to see if we could find jobs that had unusual exposures to asbestos that we wouldn't have otherwise known about. And one of the reasons our study was called the so-called Tier 1 study is we did something that actually Noel Weiss recommended to do, which was good advice, and that is the common kind of occupation analysis is ever never. So when you choose a particular occupation, you say, okay, so now I'm going to look at brake mechanics, and I'm going to compare them to every other occupation. And of course, in that occupation group would be things like insulators and shipbuilders and so on, which are going to do another job on making your denominator too high. So we took out from our never group, the people who had high a priori risk. And we still didn't find an elevated risk, but we weren't looking for elevated risk, we were looking for exposures. The thing I would have done differently, I think, this is something I think I would have done so differently in my whole career if I'd known now what I known then what I know now, is more on the public communication side. I mean, I didn't pay attention to how this study was being used, and I should have. I regret that I didn't pay attention, and I should have communicated. And even after I was called for this court case, I still, I kind of had an inkling because I'd occasionally get a note from one of the lawyers, but yeah, I think I just would have paid way more attention, and what you what your research means for the real world. And that's, I mean, I've learned that in spades and spades and spades for my bicycling research. You know, one of the things that I had no idea at the beginning of my career is how often you had to say the same thing to so many different audiences, and even to the same audience again and again and again before it sinks in. And that has been a total revelation to me. So that's something for you guys who are younger, that when you do research or when you study something, even in your own job or your own work setting, that it has to be repeated, repeated, repeated. That is amazing. But then also just knowing what's going on with your research and how it's being used. I mean, it was devastating for me to find out how it had been used all those years. It's interesting, one other colleague, some of you may know him, Murray Finkelstein. He's a PhD physicist who decided to become a physician and then an epidemiologist. And he worked for many years out of Hamilton in Ontario and also in Toronto. And when he retired, he decided that he was asked by a number of these lawyers in the US if he'd be willing to testify, and he has done that. And he contacted me right away when my letter to the editor went out and said, "Hey, so glad to see this," and blah, blah, blah. And he says, "Come and join me, let's do this." I still am not that keen, but I guess I will pay attention that if you know, he knows to contact me if they need someone. So, but yeah, I mean, that's what I would do differently.
Okay, I got an online question here. Thanks, Kay. Where are we today with asbestos exposure in Canada? Is the main source of exposure now non-workplace related, like people doing renovations on their homes?
I don't know that too much. Ed might be able to weigh in, but I would say that there's still tons and tons of asbestos in buildings everywhere. And so a lot of, and in plants using it it's probably still in pipe lagging and gaskets, and still used to a certain extent in brake linings. So yeah, it's still pretty common. I mean, when you open up walls, the chance of there being asbestos in the plaster and so on is still really high. There's still lots of floor tiles. So yeah, people working in demolition, people working in repair and buildings, there's still lots. So yeah, ship repair and breakdown. Yeah, that's a big one for when the ships are taken to be broken up in places like Bangladesh and India. It's a nightmare. So yeah, there's still plenty. I'm sure maybe Ed, you would have something to add.
Well, yeah, second your comments there. As you mentioned, all those products you listed, if they were applied before 1985 or for sure before 1980, there's a significant chance they've got asbestos in them. In the drywall and plaster, as far as I know, plaster, purely, you know, strictly speaking.
As lath and plaster, you mean?
Yeah, and lath and plaster. I don't know that there was ever asbestos in that, but the drywall finishing products definitely had significant amounts of asbestos. The drywall itself, as far as I know, never did. There's drywall that has fiberglass fibers in it to strengthen it, make it more fire resistant. But it's the finishing products, and particularly the spray texture stuff they put on the ceilings, had plenty of asbestos. The other comment I wanted to make was, you mentioned draftsmen you wouldn't think they would ever have any occupational asbestos exposure. It depended where they worked.
Yeah, of course. That was true for all of these folks, I would say.
Yeah, right. There were office buildings in Vancouver where the ventilation ducts were sprayed on the inside with asbestos insulation to suppress noise and cut heat transfer. And air blowing through those ducts, I would think, would credibly expose everybody in those buildings to way more asbestos than a lot of other occupations would get. So if you were a draftsman working in one of those places, or maybe in a shipyard where you were upstairs from where people were handling asbestos to build the ships, you could have had significant asbestos exposure.
Yeah, once again, it's the exposure, not the job.
Yeah, it's not what job you were doing, it was maybe where you were doing it, in some cases anyway. So yeah, don't ever say that because you did this kind of work, you couldn't have had that kind of exposure. You got to look way deeper than that.
Thank you. This topic hits close to home. My dad passed away from lung cancer, but he had not mesothelioma. So this is my question to you. Is you in one of your earlier slides you mentioned some separate types of lung cancer that have been connected with asbestos exposure, and basically the deal for my dad is he had tons of asbestos exposure throughout his life, and then got lung cancer at 45 and died at 47, or was diagnosed. He had it for a while, but we didn't notice it. But because it wasn't mesothelioma, it wasn't readily attributed to that, despite the high exposure. So I was just wondering what kind of are the trends in regards to those other types of lung cancer that could possibly be attributed to that, with regards to compensation and
Right.
causation and stuff like that.
Right. So I mean, I don't know the latest data, but I can say that even in the period that we looked at in detail in the 80s, there were people being compensated for lung cancer and asbestos exposure. It also bears a presumption in Schedule B, I think it is called. But if the person was a smoker, was your dad a smoker?
Never. No.
Okay, so your dad had really the best situation. Lots, of course, in that same generation that we studied, the prevalence of male smoking was about 70%. So the chance of you smoking and having asbestos exposure was greater than 50%. So that complicated things, and it complicated physicians interacting with their patients. Quite often, you would imagine that if you had a physician, they would say, "Oh, were you a smoker?" And if they said yes, that would have been the end of the conversation. So the idea, we had hoped at one time that letters would go out from the cancer agency to everyone who had lung cancer to ask that second question about asbestos exposure. And that would have been great in your dad's case, because then he could have said, I wasn't a smoker and I did have asbestos exposure. I think in your dad's situation, had he put in a compensation claim, there is a good chance that it would have been accepted. One of the things that we did in our early studies, and I'm assuming that that kind of thing has gone on since in your discussions with Terry and others at the Compensation Board, Mika, is make clear to them that the evidence of, or the strength of, or the number of lung cancer cases expected were much higher than the number of mesothelioma cases. So they knew now that they should be getting 2 to 5 times as many lung cancer claims as mesothelioma claims. So I think that the Compensation Board was aware of that. The Compensation Board was was suing the asbestos industry across Canada. I think they had a suit that was all the compensation boards. So they were, expecting to recover some of the claims they ended up having to pay out. So they weren't as likely to say no. But certainly if you're a smoker, it complicated the decision making. But there is evidence. It's one of the very interesting and rare bits of evidence of interaction, that if you were a smoker and had asbestos exposure, your chance of lung cancer was multiplicatively higher. But I mean, I think your dad would have had a good chance of compensation, and it's sad if he didn't realize that he could have put in that claim, and it's very sad if his physician didn't say anything. Don't know if he was a union member. It's sad if his union didn't tell him.
He didn't really pursue it.
Yeah, I know. Sometimes if you're sick, it's the last thing on your mind. So you just want to spend your time with your family before you die.
I was just curious what the trends are with regards to that. But thank you.
All right, well, that's about all the time we have for today. So thank you once again, Kay, and everyone, if you could join me, both online audience and in person, in thanking Kay once again.